It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my very wonderful and talented guest, Andy Grabner. Hi, Andy. How are you doing today?
Good. I was trying to make this head move, but unfortunately, for the last couple of weeks, I have a little bit of an issue with my not with the spine, or I think I'm not as resilient anymore as I used to be.
You know, are you still wearing the scarf?
I do.
Okay, good.
Yeah.
You know, I was really confused about today's episode, speaking of resilience, because I saw stuff about like chaos and resiliency. I'm like, are we having a topic about the United States? But I don't think we are. I think we're going to keep this into the IT world side of things. Right?
I think so. I think so too. But you're right. It's a little bit chaotic everywhere you look right now. But let's keep it to where we can have a positive impact, right?
Yes, exactly.
We actually have a repeat guest, and believe it or not, it's been 6 years. So it's back in 2019. So almost 7 years. Crazy. And Adrian Hornsby, thank you so much for being back. Back in the days, we had 2 recordings. One was called The Art of Breaking Things. We talked about chaos engineering. And the second one was called How to Build Distributed Resilient Systems. 6 years. What happened since?
Well, thanks so much for having me back. It's crazy, actually. 6 years. It feels like it was yesterday. It's hard to imagine.
That was even pre-COVID, if you want to put it into a crazy mindset.
It's crazy.
It is true.
Time flies. A lot has changed. Actually, I was in AWS back then. I think at that moment, 6 years ago, I probably was working on the early FIS, AWS Fault Injection Service project. Mm-hmm. We were probably producing the PR FAQ and the narrative to propose that to the organization, and joined the team to build that for 4 years. So I was principal engineer in that team for 4.5 years. And then early last year, I just left AWS, and then I went to build my own company, Resilium Labs. And it took me a bit of time to figure out what I'm doing, but it turns out, I'm helping organizations understand why the resilience practices that they have in places often don't produce the result that they intended to deliver, right? That's kind of the tagline is we fix resilience programs, right? It took me a bit to figure out. I didn't know initially that's what I was going to do, but it turns out that is what I'm doing.
I just thought of a new tagline, though, if you need another. We make resilience resilient.
Oh, that's meta resilience.
Yes, or resiliency for resilience.
And you came up with this without even the help of an AI. Look at that.
Look at that. I am an AI.
You are, yeah. Adrian, really cool to hear that the reason why you left AWS is because you wanted to start your own adventure. That's always great, and also something that admirable, because it's a big step. But I think you were also, obviously you deserve it. But if I look at your website, there's a quote from someone known, maybe someone, not everybody knows him, it seems, but we now lifting the secret, but a gentleman with the name Werner Vogels, VP and CTO at Amazon Web Services, gave you a nice quote that says, more often than not, consultants can talk the talk, but cannot walk the walk. And he talks about if you want or need to improve the resilience of your systems and operations, Adrian has proven that he can deliver. He's an educator at heart with an in-depth knowledge based on real experience, and that's that's quite something. And I think you also said he even reposted your LinkedIn announcement, so that hopefully boosted your impressions, and they have a lot of new connections.
It was quite a shock actually to see that, but it was very nice to see that. When you work in a company like the size of Amazon, and it's hard to see the impact you have. I think it's so easy to get the imposter syndrome, and certainly I had it. And it's very difficult to see your impact because there's so many people, so much happens. So yeah, it was it warmed my heart when I left to see that. It was yeah, it was very surprising, and like it was. It made me very emotional that time. Yeah.
And that comes from somebody that lives in Helsinki, Finland, and the word emotional
Correct.
from us. Yeah.
Well, I'm half French, half English, so I moved to Finland, so it's like my emotions are really like torn apart between those three, like the Brits, the French, and the Finns, like the extremes of emotions.
Yeah. But Adrian, let's talk a little bit about the stuff that you actually do. I think you're also writing a book, if I'm not mistaken. Can you quickly
yes.
talk a little bit about that?
I started writing the book a few years ago. It evolved a lot. I rewrote it 3 times, and then I finally decided, the last few months to get it over the line. The topic is why we still suck at resilience. It's super interesting. We've been talking about resilience for so many, like 20 years. Resilience engineering is a 20 plus year field. Technical resilience, so like chaos engineering, game days, is 15 years, and then there's been books, there are tools, and it turns out organizations still struggle a lot with it. And I think it's a kind of TLDR is the big problem is organization think it's a technical problem. They want to engineer their way out of resilience, where in fact it really is an organization problem. It's about the whole social technical system, like the people and the software that work with, and often the organization is, well, it's not often, it's all the time, the organization is kind of in the middle of a lot of different pressure, whether it's the efficiency pressure, which is a really big one, the pressure of delivering fast versus long-term thinking, and there's few others. There's secondary tensions that could come in the process, controlling guardrails, all this kind of thing. So there's a lot of different tensions, and all this tension affect the resilience practices that we put in place. And so the book talks about that and kind of describe the tension, goes through how to navigate the tension, how to talk about the tension, because often if you can talk about it, you can address it. Often that's the problem. We can't fix something that we can't discuss, right? So the vocabulary is so important. So I talk about this. I talk about the importance of learning for resilience, because it really is the ultimate solution, is to turn ourselves into a learning organization rather than trying to fix things through efficiency metrics and performance metrics. You need learning metrics. So these are very different. They are completely antagonistic forces. And yeah, so the book is going through that, trying to diagnose a little bit what happened, and trying to offer some solutions to that problem.
Mm-hmm. Is this also then happening in your work at Resilium Labs, that when people hire you, that most of the time you actually don't show them how to set up a chaos experiment and which tools to use and what type of load to generate or chaos experiments to launch, but more starting from trying to figure out what is holding the organization back from becoming resilient? Is that the majority of your work then?
It is almost all the work is there. Like, it turns out technically organizations are up there, right? The engineers are super smart. Like there's maybe a few things to improve here and there, but they know the things. They've implemented the practice. They've implemented the patterns. They do all those stuff. It's just the framing about the practices, how to measure it, how to think about it, how to talk about it. It kind of drives the organization towards what I call in the book theater. It's like demonstration that you have the practices versus actually learning, right? And this is because the tensions are putting pressure on what should be a learning practice, and it turns it into a performance act, right? Like demonstrate that you can run an experiment versus run the experiment to find, like surprises, or is demonstrate that okay, you run a game day, but it's very comfortable. It doesn't push you. It doesn't push you to the uncomfortable space, because you don't have time, and because there's pressure to deliver, there's pressure to do features, there's pressure to get that checkbox. So all this kind of all this different pressure kind of really turn those practices, which should have time. They should, they should let people invest themselves. The organization should it's investing time into learning, right? And then it turns into the opposite. It's hard. Like I'm not too good at expressing myself quickly, but that's kind of the idea there.
I think I get it. It's kind of about, at the end of everything, it's how important is this to us, to our bottom line. If we spend time on resilience, what is that taking away from? And if we have a problem because we're not resilient, is it a big enough problem that we're like complaining that, oh, we should have done that? Or is it like, yeah, that was a problem, but we were still getting features out, right? It sounds like it comes down to a lot to a balance of priority, right? I imagine, and is curious if this is what you see in a lot of cases, where an organization might think like, well, if we do have some sort of outage because we're not resilient, is it more cost effective to have that outage or to spend the time and resources to set up a resilient practice? Does that ever come into play, or is it not as obvious as that? We're not as blunt.
Yeah, often they don't even realize that they've moved away from learning, right? So they often start with good intention, like they actually want to find problem, and the kind of problems they want you would want to find is what in resilience engineering is called the gap between what you imagine your system is. It's called work as imagined versus what is actually happening in practice, work as done, and all those practices around resilience is really to understand where that gap is. And then often the organization set up those practices with that in mind, but not understanding exactly that it is what they're doing. They often do it because books tell them that you need to do those practices. So they start with good intention, maybe not the exact right goal of learning. And because of that, they fall into the trap of comparing themselves with a project that has a start date and end date. And then because of that, then they get assigned the same type of metrics as the projects that have delivery date. And you can't compete, resilience can't compete with feature delivery, because feature delivery is very tangible. You can see it. It has, it has customers. You get feedback out of it. You can think about it, design it, measure it, deliver it, and measure its impact. It's very concrete. Resilience is an ongoing process. It's the process of learning where that gap between work as imagined and work as done is. It never stops. And if it's successful, prevention and resilience creates non-event.
Right.
You can't really see the effect of it because it's successful. And because of that, the success of the practice often is what creates the problem. Because it's not common for organization to celebrate an engineer that spends 2 months at improving observability, looking deep into the logs to understand the small things and do improvement. It's not in the habit of an organization to celebrate near misses. It's not in the habits of an organization to celebrate the invisible work that happens in the engineers trying to maintain system. But organizations celebrate feature delivery, they celebrate heroes, fixing outages, they celebrate all this kind of stuff, which is the opposite of what you want. So it creates kind of a situation where your reward system, your incentive, also don't encourage resilience. So it's a lot of, there's so many tensions, so many habits in organization that push resilience outside of the learning kind of frame that it should take. Does it make sense?
Yeah, it reminds me too of, I don't know if you see it over where you all live, but especially like in hospitals around here, you'll see signs up on the wall that says, 0 days since our last, or 20 days since our last safety incident, right? So they're counting since they had an incident, right? To celebrate exactly what you're saying there, but it's very rare to see that kind of thing, right? So, if organizations had like on their big boards, like, how many days since their last outage, like that would just be some small change to help celebrate what they're doing, I guess.
But even that is tricky, right? Because you are now incentivizing the organization and people to try maybe not to declare outages, to actually keep that metric. And this is the hard thing to often the first intuition is to do exactly what you're talking about. But the long term effect is often eroding those things. So, for example, instead of saying many days, X days since our last outage, it would be it would create a better incentive to say how often do we find near misses, and how quickly can we recover, like more about transparency about the act of failing, understanding the system, learning. So how many, surfacing, for example, surprises, like when you do a review, when you do a game day, a chaos engineering, you want to understand what surprised you, what changed your mental model. And these are the kind of things to celebrate so that you actually incentivize people to openly talk about things that are about failure, because failure is about it should be normal. Updating your mental model should be normal. Updating your understanding should be continuous, because your system is changing regardless of what you want or not. It's changing all the time. So our mental model should change all the time, and often we play catch up, right? So we should celebrate that catching up rather than saying, "Hey, we haven't had an outage because maybe we didn't declare it, but let's celebrate that." You see that? You understand
yes.
What I mean? Yeah.
Mm-hmm. And talking about resiliency and unexpected things, I had to put myself on mute a little bit because my neighbor just decided to drill holes into their walls. So,
but of course,
exactly. It happens when you don't expect it, and you never test for this either. But fortunately, I think he's done now. He's just using the hammer. But Adrian,
yes.
The near misses. I had a conversation recently with one of our SRE leads in our organization, and this was also a big topic, the near misses. And he also did a talk at SRECon in Ireland. Can you enlighten us a little bit, the audience, what you mean with a near miss, and what this really is, and what we can learn from it, and how we should deal with this?
Yeah, so a near miss is an incident that basically got caught just before it impacted the customer, or that didn't push to the extreme, or kind of didn't push the collapse. It almost went there, could have impacted customer, but didn't. That's what we typically talk about near misses. It's the incident that didn't happen, but that we can learn a lot from. And often organization do not celebrate them. They do not look at them. They don't try to analyze them. And so what triggered the near miss basically goes back into the system without being dealt with, right? So it's like I would say it's like a volcano that doesn't erupt but creates the earthquake, right? You feel the signals, it's almost there, and you decide not to do anything about it because it didn't erupt. So you don't leave, you don't escape, you don't try to learn, you don't change your positioning, and that's really what is a near miss. And I would say if you want to improve your resilience, you really need to build a culture where analyzing near miss is happening, and being very open about it, because there's so much of information there. It's kind of the outage that almost happened, and so you can understand the dynamics, the assumptions that were there, the models, the mental models that were broken before the impact customer. Right? That's really what it is. So yeah, organizations I work with, typically we try to make them deal with near misses the same way they deal with incidents. So write a postmortem, go in and spend time analyzing them, and then really learn from them, because there's so much information there.
Yeah. So I just, if I maybe can try not an analogy but a story, because this is fresh on my mind. We work with one of our customers, and they had a queue with some default settings, default timeout before messages get thrown off the queue. I think the default timeout was 1 hour. That meant when the queue grew, and it was an order queue, and it grew and messages were older than 1 hour, they were kicked out without anybody noticing. And so
it's revenue.
It's revenue. And the thing is, right, if you think about, if let's assume you are detecting this, you're detecting that this is a problem, and you fix it because on that individual queue, you're making changes, you're changing the default, you're making the queue bigger. But if you don't tell anybody, if you don't learn, that means everybody else may also just run with the defaults and never thinks about that this is a key metric that decides how a complex distributed system actually works, because queues are everywhere, right?
Yeah, no, it's exactly that. And they probably learned a lot about how to monitor them, how to alert, what's the business impact. So it's like, there's so much learning just in there. And how did this stay there so many years without anybody noticing? What was that? I think this is also super interesting, is what happened, and missing there, and kind of the telemetry, all this kind of stuff.
Yeah. Hey, another question that I have for you, and I need to quote somebody else, and somebody else's LinkedIn, and then also something you wrote in your blog post. The quote that I read in the context of AI, AI is upon all of us. Pretty sure you're using AI to create code documentation, chaos experiments. And I think the quote was from Max Körbacher. He said, we are creating more and more, but we're understanding less and less. And then I also wrote or read your latest blog post, which was, I think it was titled, When AI Writes Your Code, Chaos Engineering Writes Your Insurance Policy. And you make one statement in there that says, traditional chaos engineering assumed code written by humans. Humans you could ask questions to. But that assumption breaks down when substantial portions of your code base emerges from statistical models. So my question to you now, because you've been in that space for so long, and with your time at AWS, and AWS one of the forerunners also when it comes to AI, all the different types of AIs that we're using, I'm pretty sure you must have also seen a change in chaos engineering now as AI is emerging to generate code. So my question to you now, what is really changing? How does chaos engineering change? What do site reliability engineers now need to change in their behavior, in the way they ensure resiliency?
most organizations are playing catch up actually with AI. I mean, the chaos engineering practice already was needed work, right? A lot of organizations and were not there yet with chaos engineering for systems that were not powered by AI, right? They were still learning. So now on top of that, you put AI, and so I would say that the big things that change is there's a lot more code being produced. So the mental model changed even faster, right? So, doing those practices and trying to identify the gap between what you think the system is and what it is even more important because it grows even faster. So, you need to really use this kind of tools like load testing, chaos engineering. There's a bunch of other things, but to try to make sense of what is being built and especially how it scales, how it breaks, how it degrades, because otherwise you will learn that in production. Right? At some point, the AI is, especially if you use automation and AI agent to try to make sense of the system, trying to recover, like autonomous agent is, for SRE is something that's coming, but eventually they will fail, right? Something is they're gonna make a bad decision, and at that moment, do you wait that AI fix itself, or do you jump in and try to fix the system? From a pressure point of view, I can guarantee humans are going to be thrown in the middle there, right? Like somebody's going to say, now we can't wait AI to fix itself, and trying to find a problem it's been driving us to the wrong direction for the last 2 hours. Let's stop this madness and put some humans there. The problem is if your humans haven't been in the code and trying to figure out the system and understand updated the mental models, well, it is going to happen in production. It's going to take time, and it's going to be a problem. So this is the interesting thing is like, I think people are trying to make sense of how to put this practice in their in kind of their AI workflow now. At the moment, my suggestion is trying to do them continuously, trying to use AI as a to make sense of data, find patterns, but stay in the loop as a human, because you really you need to learn like continuously. I don't believe system will be fully autonomous anytime soon. Like, maybe some companies will be able to do that, but like beside few maybe cloud native smaller companies that don't have too complex systems, like most companies will have human in the loop for a long time. So that I think that's the danger. I went everywhere all of a sudden, but
No, but for me, as you explained this, right? If we end up in a world where we get AI-generated code, and let's assume it works most of the time, but all of a sudden things break and the AI cannot fix itself, and then we ask the human, it feels like the classical throw it over the wall, what we tried to solve back in the days when we talked about DevOps, right? So because in the end, you say the human in the end is the one that needs to fix it if the AI cannot fix it, but it's going to be really challenging, right? If you have systems that you have no clue what's actually happening. And this is why, and I'm also very new to the whole world, but it feels the way we can really get better in this is start by writing better requirements, better assumptions, better specifications on what we actually expect from the system. Because you, in your sentence, right, in your blog post, you said when humans were creating the code, you could always ask the human, what was the intention? What was the requirement? You could always ask questions, but you can only ask the AI what we've told the AI. So that means we need to get much better in really requirements engineering and specifying, hey, an order queue should never lose orders, even if it backs up. We need to have a different plan, right?
Yeah, no, it's exactly that. And the models, I mean, the context is not infinite as well. Like you have the models can keep some of the context for few days, few weeks, but eventually they can't keep the context for everybody all the time. I mean, not that humans remember 6 months later why they made a certain decision, but at least you can you can try to understand why a decision was made, and typically you get knowledge diffusion there. You get an understanding of the evolutions of mental model. I mean, all the teams I work with, typically there's always this institutional knowledge that you can query through the people working in the team, right? Of course, the team can be changed completely, then you lose that, but which is a problem. But often you can query that institutional knowledge within the team, and that's so important during outages, right? Because often that's when you need to coordinate and find the why of particular decision so that you can fix things. Now, what I talked about the AI kind of adding more problem, it's not a new thing. Actually, in 1983, there's Lisa Bainbridge that wrote a paper, The Ironies of Automation, where she already talked about that in the context of automation in industrial systems, where she stated, again, few ironies, but the most important one here relevant is that the more automated the systems are, the more expert you're going to have to be able to fix the automation itself. That applies completely with AI, right? Because all of a sudden now you need to be an AI expert, then you need to be a system expert. You need to understand all that, so that the expertise and the knowledge is expanding dramatically there as well. So it's a very interesting time. For me, I feel a little bit sad for junior engineers because that's a lot to catch up with. So it's a lot of knowledge to get right away.
And it's bit.
I was going to say, Andy, this calls to mind a lot of the conversation we had with Jeff Blankenberg a few episodes ago. Right, so Jeff actually works here at Dynatrace, but he was using AI to help him build a website, and it was finding a balance between having AI write the code, but being able to accurately envision and tell the AI what it needs to do for him and why, right? Which is very much exactly what you're saying. Like, you still need somebody there architecting. You still need to give it the reasons. If it gives you a generic table, you're like, no, I need the table to do this and that, right? And then I think in his example, he needed another table, and it's like, no, base it on the previous one I gave you because I don't want a generic one again, but AI doesn't pick up on those things. So you have to be very aware of what you're asking it to do, right? And that's the human part of the knowledge. But I do think it would be interesting to, at the end of having it write something, have AI produce like, okay, what were the instructions I gave you for each part that you wrote? Because one thing, if you have the people who had the knowledge who are there, that's great, you can ask them. But if they move on somewhere else, then you don't have that. And if at least you have it written, like, again, smart uses for AI, have AI write why it did everything. And now at least you have your code documentation. And how many developers like writing code documentation? 0, right? So get AI to write code documentation. I wonder does anyone use AI to write comments in the code, or is that gone forever now?
The only problem with that is often when you ask AI the reason why it does something, it also comes up with a statistical answer. It's not necessarily the real reason, because the real reason is that a statistical inference. Like it's mathematic, right? So they don't. There's no real way yet to really understand the decision process of AI. But there's an attempt to do that.
Sorry. I think what Jeff was talking about, though, on the previous episode was like, you still have to review what the AI does, right? And he was even talking about like junior developers, right? Have junior developers do their code review, right? In terms of what they're going to be doing. Anytime AI gives you something, you still have to take a look at it, but you don't have to do the heavy lifting of writing it all yourself, right? So there's still, and that kind of ties into your, how long is it going to take for it to be more independent, writing all this stuff, it's probably going to still be a long time, because that's a gap that there's not only technical issues, like you're saying, it's going to be based on whatever models it is, but then there's going to be that trust factor of, okay, how do we know this is doing the right thing if I don't look at it, right? And if it's
like
by
outsourcing.
AI, well, that's exactly what I said on the call. They're going to give you exactly what you asked for. Well, I mean, outsourcing's gotten better, right? But as I said, anyone who's in the early days of outsourcing, especially, like, you got exactly what you asked for and nothing more. And like, hey, this doesn't work. Well, you didn't ask for it to work, right? But the other thing is, there's no accountability with AI, right? Whereas humans, there is accountability. So I think that all ties into that loop too, where the human still has to step in and be accountable, because there's got to be some accountability somewhere. And I don't mean to punish people, but to make sure things are doing what they're supposed to be doing.
Yeah, and this is what worries me, because at some point, somebody's gonna ask who is responsible for something, and somebody's gonna be thrown under the bus. For no apparent reason, simply because we overtrusted AI, or we just delegated everything without humans in the loop. And from an efficiency perspective, it's very, very tempting, because it goes fast. It works 90% of the time, or 99% of the time. Now, the 1% where it's not going to work, or something is going to happen, and that's when the problems are gonna be very difficult to deal with.
Yeah, I think Jeff, in the previous podcast, he also talked about he's using Git issues or GitHub issues for kind of his extended context. So he's always documenting everything in Git issues. So everything that he asked for, all the refinements, because as you mentioned earlier, right, context is limited when you have a conversation with an AI. But if you have everything well documented, you at least know what was the discussion you had. And I think with this was a little bit of a lesson learned from him, because he has been writing a blog series called 31 Days of Vibe Coding, and what he learned, how it started with his first day, and how he also changed the way he is using the AI, and tips and tricks like, put everything in a Git issue. Start every conversation with a new Git issue. Don't build big features. Break them down into smaller things. Be very descriptive, and everything documented in Git issues. So later on, the AI can also go back, or you can yourself go back, obviously.
Yeah, I think vibe coding is great. I see vibe coding as a great way to create a proof of concept, refine your ideas. But then at some point, you need to just stop it, and then go back to updating your specs, figure things out, and then break down in what I call micro tasks, like micro tasks. So that you have a lot less room for going rogue. The problem, this requires a lot of knowledge, a lot of experience, because you need to know, like you said before, you need to know what matters, and you often realize that you think few steps ahead, and then how you design those tasks, because eventually they pile onto each other. And if you do not have this long-term vision, and the way, especially in the way you accumulate tasks, right? Like, I think it creates often big problems, because you realize too late that you made a bad decision, and you start to go back and forth, and then you go back to having big problems. So it's not fundamentally different than how we did before. Like when without AI, we still did POC, and then we had to take a step back and kind of look at the bigger system, and then produce a first version of it, and break it down in tasks. It's just the efficiency pressure is so tempting with AI, because you can go so fast, and it feels productive, but you didn't have that before, because you couldn't produce the code so fast. But I think it's that this kind of pressure affect you in very, very different ways, because it's like the dopamine effect.
Yeah.
You can produce code, and it's really satisfying. It's like, yo, wow,
Yeah.
I've produced code. Well, you haven't, but it's funny.
Andy, I'm thinking like, remember way back, I think you did it might have been with, going way back, Wilson Marr, right? And I think he was saying like for performance stuff, like find something to automate that you repeat a lot, right? And it feels like AI should be used in the same way, like find your tedious tasks and use that. So if I think like construction, like you're going to build a new building, right? In the old days, first you'd still have to design the building, you still have to figure out all the safety. But then when it comes to starting it, you'd have to get like, 40, 100 people to dig the big ditch, right? To start laying the foundation. And then it's like, all right, well, now let's just get a mechanical shovel to build it, right? And to me, it sounds like the safer way through AI is we still do all the higher level tasks, and it's find those tedious manual tasks to get AI to do for you. But it's doing it, again, based on what you've designed and what you require.
Mm-hmm. Yeah.
So, kind of apply the same principles of what do I automate? It's like, what do I AI in that same idea?
Yeah, and that also went to what Jeff said, right? In the end, we still follow our software engineering best practices. We start with a good requirements document. We then think about a good architecture based on the environment we live in, based on the constraints. There might be legal reasons why you have to make certain decisions, but you need to write all this down, like as you would write it down for somebody that you then contract to do your work. And now that contractor is an AI, right? And you have different AIs that you interact with, and so you get your job done. Hey,
we go back to waterfall model.
If it's faster, though.
If it's faster, though, yeah, that's a good point.
That's an interesting idea. Like, would an old model come back if it's made much more efficient? Like, I think it's. I think it's a stretch, but I think people shouldn't completely close the door on that stuff, right? Like, oh, we can't do that. Like, well, maybe we can now.
Yeah.
Who knows?
It's interesting. I think some new models will come up. Maybe a combination of a few things.
Yeah. Hey, Adrian, I wanted to use the last couple of minutes that we have with one more topic. Obviously, we are already on the AI theme. I wanted to talk a little bit about the AI SRE agents, because if you look around, and I think the same goes true also for your previous employer, all of these vendors are producing and coming up with new cloud services around SRE agents, or however they're calling them. Giving potential insights into root cause in case something fails. So, for instance, if I make a configuration and deployment mistake on AWS because I misconfigured my API gateway or whatever it is, I can call the SRE agent, as far as I understand, and then the SRE agent tells me what is the root cause and gives me recommendations. Do you have any experience on this? Do you know where this is going, and kind of, are you excited about this, or is this just, it's just another service?
Yeah, I think it's a fascinating area. I think again, it's related to how to use AI for what it's great. What's really good at. So pattern recognition, all these kind of things. Is good dealing with large amount of data. So kind of reduce your cognitive load during incidents. So to do more of the thinking. I think this is great. Now, it's going to be very interesting to see how it evolves, because it also introduced new type of problem. It can, and I've seen that happen. It can do anchoring bias, right? It gives you, it pushes you into a direction so convincingly that you go there for sometimes to realize, and then that was not the right place, and then you spend a lot of time, and that is that's going to be a problem, I think, if you offload all your thinking through those agents. Right? So you need to I would say you need to keep thinking and use agent to verify your hypothesis rather than delegate the thinking to AI. And I think this is really what is worrying me a little bit. It also is gonna take learning opportunity away from people during incidents. That's a lot. If you ask senior engineers, often they learn the biggest lesson during outages. When you have to recover under stress, assumptions you've made, mental models that were broken. So you kind of, I think, incident is a reality check, and often reality checks are if we outsource everything, is okay. How do we learn? And then you might end up with teams that can't operate if AI is not there, because there's a lot of outages that happen where your monitoring is not there. Flying blind happens regularly, at least once a year. I have a customer that is flying blind. So yeah, I mean, there's going to be a skill atrophy, I think, happening at large scale, right? And the question is going to be, it's even more relevant now to do game days, right? To do chaos engineering, to do all these practices, because they practice your operational muscles, like, if done right. So I would say, yeah, it's great, but yeah, it's going to have to be tempered with organizations that are understanding what they're doing, what they're trading off with, right? Like, so you trade efficiency for resilience, and AI is pushing you really much towards the efficiency side of things.
But I really like what you said, and I think this is something I want to just reiterate. If we outsource everything, how do we learn? And we're taking away the learning opportunity. And I just did a little bit of vibe coding today myself. So I created a new app, and immediately the first batch that it created was like full of errors. But instead of me looking and learning what mistakes it made, I just said, hey, look at these errors, these compile errors, and fix it. And I didn't even bother to check, right? So by just saying, AI, you can do this, you're right? I mean, we don't learn. We will never be getting better in giving better instructions. And we will repeat these mistakes. And the question then is, will then the AI, at the time when it really matters, be fast and good, and then fix it really in the time we need it? Or will we then throw humans at the problem, but the humans also lost all the knowledge about...
Exactly.
So that's going to be interesting.
Yeah, I mean, it's another abstraction level, right? Like, you can argue that, I started my career in assembly, right? You can argue that we don't anymore optimize for assembly because processors have become so powerful, and so the available memory is massive. So you don't have to think about that anymore. And maybe the systems are going to be evolving so that they can fix things much better, faster than human. Maybe. But yeah, then it's like, what is left for us? Like, what do we do?
Martinis on the beach.
Martinis on the beach, yeah.
So that's how they try to sell us the dream, right?
Yeah, exactly.
No, but no, I mean, it is a little scary. I think, like, the profession of software engineering is being redefined as we speak, right? And but we've said that for every technology that has happened in the last at least 25 years. Like, I've heard the same story every time there's a new technology. So yeah, it's just, we're gonna have to reinvent ourselves yet again, and that's it.
Yeah. Hey, Adrian, thank you so much for the conversation. Is there anything else that you wanted to get off your chest? Any other topic before we close out?
Wow, like that's
an open. I know this is maybe the door opener for another episode.
Yeah, I would say stay curious with incidents, and keep learning. I think if there would be one thing I would strongly encourage everybody is to see the discipline of resilience, kind of the as a learning practice. Nothing else. It's not the project that you need to track through efficiency metric or performance metric. It's a learning opportunity to understand how your system really behaves versus what you have in mind. And whether it's AI, whether it's, all these kind of tools still needs to be within that context of learning. So I think when you start using AI, think about how is it helping you learn versus how you outsource learning. That would be my last comment.
And I think that's going to be an awesome soundbite, Brian, if I may say.
You can say that all you want. I'm kidding.
No, see AI as a learning opportunity, and not just as an outsourcer.
Cool. Yeah. I think if people can understand resilience is learning, that's a good thing.
Yeah. Cool. Adrian, thank you so much. All the best for your new business, for Resilium Labs, folks. We have, we'll definitely make sure that all of these links will make it to the podcast description as well, and also to your blog. And also, if there's anything else, just let us know that we should link to.
Once the book is out.
Exactly.
And I'll just also add.
I'll send you a copies.
Thank you.
I'll also add, just remember to analyze your near misses. I really like that that lesson as well. It's very easy to say, we dodged a bullet on that one. Let's ignore it. Fantastic advice. So thank you so much for being on. It's been wonderful. Hope you have a great rest of your week.
Thank you, Brian.
Hopefully talk to you soon. Bye-bye.
Bye-bye.
Bye-bye.